It's your friendly math tutor, Miss C here, and today we are adding rational expressions. We have two terms separated by an addition sign or a plus sign. When we add fractions, we have to have common denominators, and when we are adding rational expressions, that rule pertains. So I'm looking at our denominator here, and in our first term, I notice that we have an x minus 3 in the denominator, and in our second term, I notice that we have an x minus 3 in the denominator. We also have an x plus 1 in the first denominator, and we also have an x plus 3 in the second denominator. The denominators have to be exactly the same. So what I notice in the first denominator, that's this one, is I'm missing the x plus 3 that I see here. So I'm going to go ahead and multiply this denominator by x plus 3. And in math, what we do to the denominator, we do to the numerator. Okay, remember, I'm working toward getting common denominators, okay? And in this denominator, I notice that I have an x plus 1, but I don't have an x plus 1 in this denominator, so I'm going to multiply by x plus 1 here. And this doesn't have parentheses, so I'm going to go ahead and parenthesis that because I'm multiplying the whole numerator by x plus 1. So let's just go through and make sure that we have all three of the binomials that are being multiplied by one another in the denominator. So we have x plus 3 here. We have it here. Okay, check. We have x minus 3 in both, and we have x plus 1. What that means is we now have a common denominator. So if I rewrite this, I'm going to have x plus 3 in the numerator minus or times x minus 4. I'm going to have 2x plus 1 in the numerator in this term and x plus 1. Now, because our denominators are the same, I could write this as a single denominator of x plus 3 times x minus 3 times x plus 1. But we're not done because we still have that plus sign in the numerator, and we either and multiplication of binomials as well. So we're going to go ahead and we are going to FOIL this. So we have x times x, which is x squared. We have x times negative 4, which is negative 4x. We have 3 times x, which is 3x. And we have 3, trying to grab another color here. We have 3 times negative 4, which is negative 12. Okay, so that is FOILed out or distributed out. And now we need to add that to what we have here. So we have 2x times x, which gives us 2x squared. We have our next term, which is 2x times 1, which is 2x. We have 1 times x. X or 1x is what we get. And last but not least, we have 1 times 1. Okay, so I'm going to go ahead and I've color-coded these, but I'm also noticing that I've got some like terms in both of these. Okay, and I guess I should probably be really accurate here and write my denominator before we start combining things. This is the problem with these problems. You have to write so much. So I'm going to go ahead and I'm going to notice that I have x squared terms here and here. So I'm going to go ahead and add this together. So we have x squared plus 2x squared is 3x squared. We've got all of the terms I highlighted in green. We have negative 4x plus 3x. So that gives us negative x. And then we have 2x plus x, which gives us 3x. So we have 3x minus 1x, which is 2x. And then we also have our constant terms, which are negative 12 and 1. So our constant terms, we are going to combine. So negative 12 plus 1 is negative 11. Okay, I meant to make that a different color, whatever. Okay, and now we still have our denominator. So at this point, if I'm dealing with a rational expression, I'm curious if I can simplify anything else. And I'm thinking about, I could pop this numerator into the quadratic formula. These are ugly numbers, 3 and 11, negative 11. They're both prime. There's no way that when I combine those, I am going to get 2x. If I were to factor, that means if I put this in the quadratic formula, I'm going to get decimals. So This is as simple as it gets. In the next video, we'll look at an expression that we are adding together that we can actually factor the numerator and simplify this even further. All right, thanks for watching. Till next time, remember, you've got this.